360 Faculty Development Program on AI, IoT and Data-Driven Mobility in Smart Cities. Today we are greatly honored to have with us our esteemed speaker, Dr. Surajit Kundu, Assistant Professor, Department of ECE, NIT Jamshedpur. And now I take this privilege to introduce our eminent speaker. Dr. Surajit Kundu is an accomplished academician, researcher and innovator in the field of electronics and communication engineering. He obtained his Dept in Electronics and Communication Engineering in 2009, followed by an MTech from the Department of Electronics and Electrical Communication Engineering, Indian Institute of Technology, IIT Kharagpur in the year 2012. He earned his PhD from the National Institute of Technology, NIT, Sikkim in 2018. A prolific researcher, Dr. Kundu has published 98 research papers in reputed SCI indexed journals, international conferences, and book chapters. He also holds 9 Indian utility patents, of which 3 have been granted and the remaining have been published, reflecting his strong commitment to innovation and technology development. His outstanding research contributions have been recognized through numerous prestigious awards and honors. He received the Young Scientist Award from the International Union of Radio Science during the Asia Pacific Radio Science Conference 2019 held in New Delhi. He has also received several Best Paper Awards, including at the IEEE Space Young Faculty Leadership Program 2025 in Bengaluru, NERC 2022 at IIT Guwahati, and I3C 2020, among other reputed international conferences. He has successfully completed and is currently leading 8 externally funded research projects sponsored by prominent Government of India agencies including ANRF, DST, TechSmin, HEFA, JCSTI and TEQIP, serving as principal investigator for projects with a cumulative funding of approximately 3.4 crore rupees. In addition, he has coordinated 12 workshops, faculty development programs, short-term courses, and skill development training programs funded by IEEE, MSME, AICT, SERP, DST, and TEQIP, with total grants amounting to approximately rupees 42 lakhs. Dr. Kundu is a senior member of the IEEE and an active member of the Wireless and Antenna Measurement Society and the International Union of Radio Science. He has served as an associate editor and a regular reviewer for several reputed international journals. Dr. Kundu has been consistently recognized among the top 2% most influential scientists in the world. In the single year impact category for 2023, 24, 25 as identified by the Stanford University Elsewhere Global Database. With his remarkable academic achievements, impactful research contributions, and extensive experience in research, innovation, and professional development, Dr. Surajit Kundu continues to make significant contributions to the field of wireless communication, IoT, antenna systems, and next-generation communication technologies. His expertise and dedication make him a highly sought-after speaker, mentor, and researcher in the global engineering community. With this enormous introduction, let us all welcome our eminent speaker who will enlighten us today with his enriching topic on IoT and GNSS technology-based smart precision farming and community development. Let us welcome him with a rounded applause. Moving on to the felicitation round, may I now request Dr. Novanil Bose, Professor Dr. Novanil Bose, Principal SIMT, and Dr. Shafiq Ahmad, HOD, Department of Management Studies, to kindly come up to the dais and felicitate our eminent speaker with memento, utorio, and a bag. In continuation to the felicitation program, we would also like to felicitate the respected scholars of Surajit Sir, Mr. Rajkumar Mandal and Mr. Samrat Das. So may I request our Principal Sir and Shafiq Sir to kindly felicitate his respected scholars with the badge and utorio. Thank you, sir. Now I would request our eminent speaker, Dr. Surajit Kundu, to please start your session. The floor is yours, sir. Thank you.
Very good afternoon and namaskar to all and everyone. So I know this could be quite a very tough session considering the impact of heavy lunch. At least I got a heavy lunch. Thank you to the organizer. And so with the skipped few portion. So otherwise you might be knowing that I used to work here in a certain period, almost for 2 semesters. So I am privileged to be here, and it's very emotional as well as some special moment for me returning here to deliver a lecture. So to begin with, let me have some let me give you some idea about where I belong nowadays. So I used to stay in a very small city, which is known as within a very small state, obviously, that is known as Jharkhand. and within the industrial belt Jamshedpur, we are having one NIT there, National Institute of Technology Jamshedpur. Now, we might be the only NIT which is surrounded by more than 4,000 MSME and very big industries. Like all of you might be aware of Tata Steel, then Ramkrishna Forging, RSB Group, and there are so many industries are surrounding to the NIT Jamshedpur. In the automobile cluster, electronic cluster, these things are there. So we are having privilege of getting very good placement, that is almost 95 to 96%, and that is the only reason I could say, not us, not the faculty members. Obviously, the only reason is the having good placement, because of which we are getting a very good number of students, which are having comparatively lower rank than some of our neighbor NITs and other institutions. So these are some infrastructure you could see here. We are not having excellent, but we could have some moderate infrastructure. That much I could say in our institution. And right now we are looking to develop one central research facility center where some major equipment like SEM, then XRD, then metal 3D printer, and then 110 gigahertz DNA, and one more micro machining lab. So these 5 equipments are approved by DOG, and we got a fund of rupees 20 crore to develop that infrastructure. So it will be a big advantage of that region, and obviously it will be open for all. Might be some nominal payment will be there to access those facilities.
So towards the left.
So this is some places of interest in and around our institute. So one is the Dalma Sanctuary, you could see there some picture inside the Dalma Sanctuary. Next one is the very famous Jubilee Park. Many of us used to go there in our childhood. Then there are some lakes in and around us like Chandil Dam, then Bordi Lake, then one very Dimna Lake. And we are having many religious places like Sai Temple, then Bhubaneswari Temple. And the last picture here, this might be no less than a temple for us, for the Bengalis, because it's the the home of the great novelist Vibhuti Bhushan Bandyopadhyay. He used to stay his end life here. So that is in Ghatshila. So that is only 45 minutes drive from our institution. So here, let me acknowledge few people. I must acknowledge them. So I am having some co-authors from different institutions. So I could not take all of their name, but you could see them. Their names are at least mentioned in the slides. So I'm thankful to my research scholar team. We used to have a lot of group activities, group gathering, and the PDF who done under my guidance. So all of we are having very good bonding and team meeting and other things. And I'm also thankful to the funding agencies and collaborators who helped me to grab the projects and funded my works. So starting from NRF, DSP, then TechSme, MSME, IFA Higher Education Financing Agency, and JCST as well, Jharkhand Council of Technological Innovation, then DRDO. And I am also thankful to CIIC. CIIC is our incubation society, from where we got a 10 lakh grant recently, and we started our own startup, and that is the outcome of this project only that I will deliver. So let me goes back to my old days. I was here around 2012. So these are some picture of that time when I used to be here. So thanks to Facebook and other social networking site, I used to get those pictures in last few days. So these are some students. I was with them, and that time we used to have some, I believe now also we have this kind of tournaments within our institution among different departments. And in my class, I might not be a good teacher, so that's why people used to, apart from learning, they are more motivated to discuss, gossip and other things, and I also enjoyed such activities. So these things are there, you could see in the picture, and this is one photograph was taken in Strand Road. Many of them are now having very good profile, like Prantik is there, one person is a movie director now, Shourabh Neil, he used to be here in, other one is in Wipro. So I could remember all of them. Then we used to go there. Some of us here in the participant, they are also there that time. Like Gautam Rai is there. Then Robijit Dwadi used to teach mathematics that time. So we visited his place during his marriage. And a person contacted me. He was my batchmate during my BTech journey. So thanks to Dept. And she is there in that photograph. I only got this photograph. We might not be happy with the quality of the photograph, but please excuse me for that. So anyway, I know this is not anyhow related to all of you, but just to refresh my mind, I included this slide. And I must thanks to the management of SKJ. That time, Sri Vijay Gopal sir was there, and Chanchalda was there. I used to be very close to all of them, but he was, Chanchalda might not be now available, he passed away. So that's a really sad news. Anyway, so let's start a little bit. So I have seen this session is given a slot of almost 2.5 hours. So what we have decided, I divided it into two sections. In the first section, we will be discussing little bit concept. I will not, do that type of brainstorming that it will create some negative impact. So all of we know the basic things, most of us obviously. So we'll discuss a few basics that are required to implement my work. Then I will go to the case study, that what we did in that project and what are the outcomes we have achieved till now. And then we came with some hands-on kits here. So that's why my two scholars are here. They will be demonstrating that hands-on session, so that it can give you some real idea that how could we proceed further if you are really interested to carry such work. So IoT, in a sense, the way we used to consider IoT, like suppose I make this system, any electronic gadgets with a connectivity, internet connectivity. So some people could say it is having internet access, so it might be a IoT device. Yeah, that's partially true. But at the same time, there are two other components we need to remember, that whatever the data your gadget is generating or taking, that need to be stored either in cloud, or you need to make a real-time analysis and real-time outcome based on the edge, or we could make a decision on real-time, so real-time decision making would be another part. And then you should deliver it using some platform, web platform or app platform. So then you could integrate a complete IoT system. So if you consider IoT as an onion, and if you peel the onion, what we will be getting inside? We will be getting inside some sort of sensors. The multi-sensor environment will be there at the core unit, and then the data that is collected through sensor, because up to this level, it is the sensor module only. So this is not IoT at all. This is only the sensor unit. And the multi-sensor unit will be gathering the data, and this data we need to transmit wirelessly. Now how could we transmit wirelessly? Because Wi-Fi is a free wire, so it is a ISM band.
Sir, I have one question.
Yes, please.
Why we need multi-layer sensor?
Multi-layer in IoT you are asking?
Why we need multi-layer?
No. Which portion you are mentioning first?
Sir, you said we need multi-layer sensor system, right?
No, not multi-layered. I said multiple sensor system, multi-sensor module. You could use single sensor, but in most cases, a single sensor could not perform multiple tasks. Suppose in our project, I will be showing you. Our target was to gather the environmental data as well as soil data. So if we use some sensor like NPK is a popular sensor, if we use that sensor for soil characteristic analysis, that same sensor could not be useful for environmental data analysis. So that's why I mentioned multi-sensor module, not multi-data. So here, after gathering the data in the sensor unit, we need to transmit the data wirelessly. So here, most promising is Wi-Fi band, or nowadays 5G. 5G is not a part of this lecture, otherwise we could discuss it in a long duration. So at present we are having frugal 5G. So if we consider frugal 5G also, then obviously our data rate will be little higher. But we need to consider the spectrum procurement, and that things are related here. And another one is the LoRa. So that is the long range IoT. So that is also there, and for short range connectivity, GP and UWB, these are the popular choices for data transmission. So that is the second part, the data transmission wirelessly. And then comes the third part, where we can store the data completely using the cloud, and real-time analysis we could make. If we use the edge, that means it not only stored data, but at the same time it is making some decision using the data. So data processing will be there, data analysis will be there, and you could have a display to demonstrate your data. So if we consider the technology, we are for connectivity, as I mentioned, we are using 5G. Obviously 5G is having very ultra low latency, and latency, is it any idea about latency, ultra low latency? What could be the advantage of ultra low latency?
Real time
latency low means obviously your data transmission will be very fast.
So we can real time monitor.
Yes, real time monitor, that is also correct. These are the outcome. So just let me give you an example. Like so if you goes back, because all of we are almost in the similar age group nearby. So if we goes back to our old days of telecommunication around 2010 or 2011 at that time, and if we are traveling on a very high speed car like train like Shatabdi or Rajdhani that time, so often you might be facing that network connectivity was lost during the high speed train. Nowadays it is, we could not see that type of things. Even if you are traveling Vande Bharat at a very high speed, and usually we get a stable connectivity until or unless that is a very remote location. So that is one thing that is related to the improvement with latency. Second thing is the LoRa wireless network. That could be also useful for that. But the main challenge is to keep the power low, because nowadays green communication is a real challenge, and that is the target of all the government and activists. They are always claiming that we should not harm the animals and biodiversity, everything. So that's why keeping power level low, at the same time providing the long range coverage. These two are actually contradictory. To satisfy these two things are very challenging. Then Wi-Fi 6 is the
How it is helping in power? How it is helping in power?
Which one is helping? No, this is not helping actually. What I mentioned, this is a requirement. Obviously, it is not helping. To make or to keep power low, there are different strategies. Like nowadays, if you consider the spectrum allocation for communication, if you consider the 5G or even any standard communication system, even the futuristic 6G, one thing I could assure, or anyone could assure who are related to ITU, that communication, mostly the people communication or mass communication, will be sub 6 GHz band, that is up to 7.2 GHz, not beyond that. Obviously, you are having 24 GHz 5G band, 28 GHz, that is new radio 5G FR2 spectrum. You just Google it, 5G FR2 spectrum, you will be getting a lot of bandwidth and its spectrum. But the problem with millimeter wave and terahertz wave is that there are two issues. One is that its penetration will be very high. That's why whenever you will be going in front of an X-ray unit room, you will be seeing there is a caution display will be there. Because whenever you are improving the frequency, the penetration is getting increased. So it can penetrate further. That is one challenge. And second thing, its propagation, free space propagation will be reduced. So if we implement 5G or 6G in millimeter range, the number of base stations we are having nowadays to cover the particular geolocation, we need to increase at least 100 times more base station we need to implement, which is not possible like a country like India, which is having very high population, and it will also increase the cost. So that's why we cannot just simply increase the power to transmit data to a further point, right? Because that is not economically beneficial. So the solution, like from antenna engineer's perspective, one solution is to improve the gain. From communication perspective, you need to improve the repeater accuracy so that it can boost your signal further. And there are floor planning optimization techniques so that you can get maximum power at any certain point. So there are different strategies. So I never said we are getting low power because of this, but I mentioned getting low power at the same time getting longer range coverage these two are contradictory, and this is the real challenge where we can contribute as a researcher. Yeah. So for edge, there are some specific cloud platforms we can do for cloud storage, like AWS, that is for Amazon, is providing that service. Azure is from Microsoft, and then Google Cloud. These things are there. So usually they provide cloud service, but we need to pay a lot. And till now we are lagging as a country to create our own cloud storage. In intelligence part, to make a decision using your data, we can use predictive analysis based on artificial intelligence or machine learning. Then digital twins is also nowadays a buzzword. And in hardware level, obviously we need sensors, actuators, so these things are required mainly. And microcontroller board. Microcontroller board, in our school students also nowadays play with Arduino board, but that is having typical limitation because it can go up to 10 megahertz frequency or 25 megahertz frequency. So for high frequency operation, that is not a perfect choice. And we can use Raspberry Pi. Better one board, I don't know how many of you are aware of that. We can use Latte Panda. Latte Panda is much better option, but obviously it is much more cost. It is not cost effective like Raspberry Pi, or Arduino is actually the cheapest solution. Then for security purposes, the blockchain technology is there to keep your data communication protected. We could have OTA firmware updates. OTA means like now we are getting in our mobile phone, we are getting some updates, security patch update, these things. So that is one example of OTA firmware updates. So we don't need any connectivity, physical connectivity. Wirelessly we can send the update required to make our OS more secure. So if we consider the commercial aspect, the global IoT market, you could see that it is valued around 1.18 trillion, which was projected in 2023 as per Grant View research data, and it is expected to reach up to 2.65 trillion by 2030. So huge, progress is there, and top sectors where this money will be floated, like industrial IoT, that is also known as IIoT, smart building infrastructure, smart city, healthcare, retail, transportation, rural development, agri support. So these are some of the key aspect area where IoT will play a big role. Okay, so challenges already I mentioned. Power is one challenge. Data management is another big challenge because you can generate a lot of data, but handling those data in an efficient manner with the computation, because we don't have GPU facility a lot. So that is another challenge. And the platforms will be heterogeneous, so maintaining the different platform heterogeneous compatibility, that is again a great challenge. So these things we need to remember. Then let us discuss about the today's idea, that is the application of IoT in smart farming basically. So smart farming in the sense that compared to the traditional farming where we are use our the technology or the knowledge we are getting from generation by generation, that we are mostly using. But when you are adapting our learning along with the technologies, and like IoT sensor, we could use AI/ML, we could use the satellite navigation and automation for the betterment, for better production, better fertility, better waste management, irrigation. So then all together we are calling it smart and precision farming. So again, if you consider commercial aspect of this market, it is having a valuation of 28.65 billion in 2024, and it is again projected that it can reach up to more than 54 billion by 2030. So a compound annual growth rate is expected to be 10.5%, that is internationally, globally. Whereas in Asia Pacific, we are having the major market, 35% market contribution within Asia Pacific, but India is not leading here. Mostly Japan, China and Australia are the leading countries. So surely we need more investment as well as more researcher in that domain, so that we can also make our mark. I mentioned the application areas like precision farming, smart irrigation, then livestock monitoring, greenhouse management, drone-based surveillance using UAV, AI-powered yield prediction. So these are some of the application areas of smart and precision farming. And if you compare the market report of Indian, perspective, from India's perspective, we are getting that we are expecting a compound annual growth rate that is more than double of the global rate. Global expectation is 10.5%, whereas we are expecting in our country it should go up to 21.4%. So that is huge, and it is not a fake, assumption. The reason is that if you consider the growth, particularly for IoT sector, it is also more than the global aspect. That is 14.6 compound growth rate we are calculating annually. So government has also taken many initiatives in that direction, like Digital India, Agri Tech platform, PM Kishan direct benefit transfer in the DOT accounts, then NECPA, that is a National E-Governance plan. Whereas the main challenge in our country, we are having land in small models. We don't have a huge landfall to a particular cooperative farming agency or any farmer as an individual. So managing the technology within a small farm system is really challenging, because your production to return, that is the revenue will be less in that case. So that's why that is a very big drawback in our country. Then second challenge is the literacy, digital literacy. At least we are not still that much digitally literate. Although we are having mobile phone, but mostly we are using it for entertainment purposes. So to change the mindset is again a big challenge. And the connectivity is still not good in a rural environment. And the fragmented supply chains. We don't have a complete supply chain. Suppose I am producing tomato and I need to send it to foreign countries. That happened. One of my friend is a farmer in Hooghly. He is IT person, but he is having farming land, and he produced tomato. And that time during the war there was a crisis. The Pacific countries, they wanted, not Pacific, the Arabian countries, but he could not get the clearance due to because their licensing part is very strong compared to our country. So he could not get clearance because of the delay during transportation. So fragmented supply chain is a big issue. Now it's not like that, people are not working. We are having many agri startup. So some startup and companies I have mentioned here, these are very popular and generated a lot of revenue. Cropping technology, there are 3 years behind that industrial private limited company. Now cropping technology, what they did basically, they integrate the AI-based prediction and they provide the advisory to the farmers that what they should do for better crop production. Second one is the DHAT. So in DHAT, they are also having a agri platform, but not for improvement of the crop production, but their target is to make a reliable supply chain. So there is the supply chain process. The next one is the AgroStar. AgroStar's target is the digital agronomy and the sensor-based farm data they generate and provide to the end user. So these 3 case startup and industry I have mentioned, which they are working on every best region. Apart from IoT, the second topic that will be required for my project is the satellite navigation. So I will be discussing little bit about the satellite navigation now. So satellite navigation, like all of we are in our mobile phone are using GPS, global positioning system. But do you know that how much accurate is it? The GPS is providing a data to us which is 5 to 10 meter accuracy. Matlab if GPS is located in this point with some latitude longitude, there could be an error up to 5 meter to 10 meter range. So that is the accuracy of GPS. Now it seems to be okay for many people, many of us. It's okay, 5 meter, 10 meter, to kya was, kam chal jayega. But there are some applications like satellite clocking and precise farming, where this 5 to 10 meter error margin is even not reliable. So we need to reduce that margin, and we are looking for centimeter, even millimeter level precision. So instead of 5 meter, 10 meter, the data precision will be in centimeter level. So that's why GPS is obviously a part of GNSS. Global Navigation Satellite System or multi-GNSS constellation comes into the picture. So if we consider the GNSS, there are different type of satellite positioning. One is the called standalone positioning. In standalone positioning, the concept is like that. There is a satellite. The most of the GNSS satellites are in MEO. MEO means medium Earth orbit. That is almost 20,000 kilometers above the Earth's surface. So you are having a static rover. Rover means rover is the receiver unit where you are collecting your satellite data. So you are having a rover and there is a satellite. So we don't need any other unit there. So standalone means you will be a static rover unit and there will be a satellite who is making the communication. So there are two methods, single point positioning and precise point positioning. I am not discussing in detail because this is not the appropriate platform to discuss these things. Otherwise it will seem a classroom. Second one is the relative positioning. Relative positioning, in the case of relative positioning, we are not considering the satellite only, but we are providing a base station. Like जैसे हम लोग मोबाइल पे बात करते हैं, there is a tower, base station होता है, जहाँ से सिग्नल आता है. In that case also there is a base station. Our base station location is first logged in the emulator or software, and then we will be having another rover unit, and then the comparative data will be utilized to predict the location precision. So there are a few methods like differential GNSS, real-time kinematic RTK, and post-processing kinematic. We have used post-processing kinematic, and I will discuss why we use PPK. RTK is constantly you need internet connectivity between base and rover. There you would have two rovers, you need one base unit, and you need a continuous connectivity. But in PPK, we could do the data collection, and after that we need to do post-processing. So using any pen drive or any storage, you can collect the data, and then you can do the post-processing. So in PPK, the advantage is that we don't need internet connectivity, because this is very challenging. In rural areas, we might not have proper internet connectivity. I have a project on mining sector, smart mining. So in the mining region, I never got very good internet connectivity. So in such application, we need, basically the PPK technique, then RTK. Now, if we consider the different global navigation satellite system, as I mentioned, GPS is governed by USA. So it is having 32 satellites they have launched till now, out of which 28 are active. Then Russia is having GLONASS. So these are the global coverage they are providing. So GPS is you will be getting in USA in any portion. Almost 97% of the earth is covered by GPS. Then there are GLONASS that is from Russia. They also launched 25 satellites, out of which 22 are inactive, and frequency bands are L1, L2. Galileo is for European countries. They are having 26 satellites they have launched, out of which 22 are active. Beidou is for China. They have launched the highest 49 number of satellites. And from our country, Beidou is giving better constellation in most of the areas. And we are having 44 active satellites. There are some regional coverages also. Like in India, we developed our own regional system, which is known as Navi. Earlier it was known as IRNSS, now it is called Navi. In Navi, we have launched 7 satellites, out of which 3 are in active mode now, and the bands are L1 and L5. And Navi is still for ISRO people they are using. Most likely within few years it will be used by all of us. In common people they will be having Navi also. And QJS is the regional satellite for Japan. They have also launched 5 satellites, out of which 5 are in active mode. Now, one question might come. Already USA providing the constellation to all of us. China is also providing. Why should we go for a separate constellation for us? The reason many of you might be aware of that. During Kargil war, India, the government of India, Vajpayee was that time Prime Minister. So Mr. Prime Minister requested the USA President to provide the data, GPS data. But USA had a good relation with Pakistan, so they denied, and that creates a loss, huge loss for our country. So then they took that mission that we should build our own navigation. So that is the story behind Navi initiation. Okay, so there are, as I mentioned, these are the different techniques. and we could have a comparative quick comparison between the technique. So if we consider the single point positioning, that is a standalone technique, it needs a single antenna, single receiver basically, and PPP is also standalone. So here also we need a single receiver and single antenna. Whereas RTK and PPK, we need dual receiver, one for base station, another one for the rover. Rover is the receiver. Internet connectivity is required compulsory for RTK. Processing, PPK is the post processing. PPP is also post processing, but PPP is the standalone. Time requirement to lock the base station, that is 24 hours in case of PPP and PPK, because these are post processing techniques, whereas other two are the real time techniques, so instantly you can read the data. And if you come to the precision, you could see the precision, centimeter level precision is very easily available in RTK and in PPK. PPP can provide up to millimeter level, but PPP is little complex compared to these two. So we have considered the PPK technique, considering all these aspects for our project. And these are actually different GNSS error calculation. So we need a good MATLAB, idea to do so. Anyway, last topic that is required that I will be discussing is the cognitive radio. So cognitive radio was a very popular thing nowadays. You might have heard about SDR, software defined radio. So it is just the next step than software defined radio. So SDR and cognitive radio, this was invented by a great person known as Joseph Mitola. So during his PhD, he proposed SDR. So during his PhD, he did the groundbreaking word SDR, and just after PhD, he published a work on cognitive radio. So what is the logic behind that? I will not go to this type of definition. Papers obviously you can download and you can study, but let me give you a very understanding of this of cognitive radio. So suppose our plan is to start journey from our home. So what is our expectation in our mind? If there will be no one in and around us, I will be the only one who will be traveling through the road. So I will be the only one I can walk through the road. But what is the reality in India, highly populated country like India? This is the situation, especially during a festival or a cricket final if India win. So we will be stuck in between a huge population. So we could not find our way. Then consider this photograph. So there are two lanes. So this lane is for pedestrian, this lane is for cars. So there is a morcha, people are going through this lane, but some person who are not having that much patience, so smartly what they did, they just jumped to the another lane, because in that lane there was no car at that time, so they easily overtake the other people. Okay, so this is cognitive radio concept. Actually, if you just compare this with cognitive radio, whatever the spectrum allocation, spectrum is frequency allocation, whatever the frequency allocation was done for different wireless technologies, this is very much congested. Now technologies invented day by day, new technologies are added to the existing technologies, and we are not getting new spectrum. Because spectrum is the most valuable things. You could remember 2G spectrum, जो ये हुआ था ना, कुछ राजा कोई अरेस्ट हुआ था, वो टेलीकॉम मिनिस्टर था उस टाइम पे DMK था. So there was a big scam during that time. That spectrum is the most valuable things in communication system. So we have to manage spectrum dynamically. So suppose for mobile communication, a particular spectrum is given. For GSM 900 MHz, or some spectrum is allocated. Now it is not like that 24/7 that channel is blocked by user. Sometimes it could be free. So when it is free from mobile user, why could not we use it for other application? So that is the concept of cognitive radio. कि जहाँ पे खाली मिले स्पेक्ट्रम उसको दूसरे टेक्नोलॉजी पे काम पे लगा दो, ठीक है? So that is the way cognitive radio comes into the picture. So here this is one photograph for realistic data. It was taken much earlier in 2003. They have taken a band and compiled all the technologies together, and you could see there is no white space available. Almost it is full with different spectrum allocation. So there is no space available that time to introduce new technologies or to provide them the spectrum. When realistic data calculated that how the bands are utilized in practice, they have identified that there are a lot of white spaces. That means although the bands are allocated for different technologies, but it is not utilized continuously. So that's why there are some availability of that. So then it comes to the picture, why should we waste this spectra at that time? Why don't we utilize for other technologies, or why don't we allow other technology to utilize that available spectrum? So that is the cognitive radio concept. So there are different things that comes under cognitive radio. One is the fully cognitive radio, where we are optimizing all the parameters, channel parameters, and this one is the more realistic. This is spectrum sensing cognitive radio, where we are limited parameters we are optimizing. Then it is having three models: dynamic exclusive model, open sharing model, and hierarchical access model. I will just brief about these things. So dynamic exclusive model means, like suppose you are traveling, but it is and you are having Geo SIM card. Now it might not have. Geo is having Geo installed their base station throughout the country. They can borrow the base station of other service provider, right? So when you comes to a location where Vodafone's or maybe Bharti Airtel's base station providing much more better power than Geo, so in that case you could be a HLR there VLR there, and Geo could send the request to allocate your spectrum in the Bharti Airtel base station. If the spectrum is available, you could be allowed as a secondary user. So these type of things are called dynamic exclusive model, where cognitive radio interchange happened mostly in interrelated technologies. Second one is the open sharing model. One classical example of open sharing model is Wi-Fi. So in Wi-Fi, until or unless your institution or your organization is keeping some cyber kind of security, it is free to all, anybody can access. So open sharing model means if it is available, you can join in that network. Then hierarchical access model. Hierarchical access model means there will be some priority set, and based on the priority, the technologies will be allowed. So it is having three types: interwave, overlay, and underlay. So underlay example is the UWB. Overlay means both are simultaneously can be done, but one's power level will be very high, another's power level will be very low. And interwave means कि एक के बीच में दूसरा, मतलब कोई टेक्नोलॉजी यूज हो रहा है, जहाँ पे नहीं यूज हो रहा है वहाँ पे दूसरा टेक्नोलॉजी को यूज किया जाएगा. So that is interwave. And underlay is the UWB. UWB here you could see it occupies a very huge spectrum, but its power emission is very low. Whereas it is having primary users, its power emission is very high. So obviously even if they are interfering, but actually they are not interfering because of the very high noise margin. So very high power level differentiation. So these are the cognitive radio examples. So these three technologies mostly we have used in our work. So let me just brief about the motivation behind this work, because we know that our country is mostly mostly dependent on agriculture. At least 60 to 70% of the population of our country is somehow related to the agri industry or agriculture field. But if you took the data of GDP contribution from agri sector, that is hardly 18 to 19%. So as per the population involvement and GDP creation, these are not matching at all. So that's why we need some technology incorporation to make it more profitable, so that it would be sustainable as well. So in that purpose, we have considered this project and we have applied it to funding agencies, and I am thankful really to Higher Education Financing Agency, which is a joint venture of Ministry of Education and Canara Bank. They have supported us 48,43,000 grant for 3 years for this work. So here, second reason you could see that we have, because we cannot cover all the agri industry in one project, so we have took the tea industry as the pilot project. So tea sector, there are some more specific challenges. Indian tea production is very good, and you could see the share. Assam is the most, they are having the first place in terms of quantity. But if you compare the quality, obviously our Darjeeling tea is having the best quality. Now we need to take a decision that should we invest more on quantity, or it should be a balance between quality and quantity. So to ensure sufficient quantity with better quality. That should be the target. So what we did in this work, second thing, let me discuss. There are some diseases associated with tea plantation. So these are the common pesticides. These are used during the tea production, and these are the diseases related to the tea. And we have worked with this disease detection with the help of IoT also. IoT and AI, mostly AI, image enhancement and image processing, we are using there. So our objective is to build, a compact, affordable IoT sensor-based, GNSS-based module, which will be collecting the data. Then it will send the data wirelessly. We will provide the satellite navigation using post-processing kinematic. Then we will be developing a robot system. Robot, as I mentioned, the receiver system to store in different positions. And then we will be making a decision based on the machine learning. What should be the temperature, what should be the soil characteristic. So we will study the data for 2 years. 2 years is the crop cycle, and then we will make a decision, and that decision will be provided. Now this is the customized solution. This because one tea estate in Darjeeling, another tea estate in Lataguri, if another tea estate in Munnar, if you compare, their geolocations are completely different. So their aspect, their necessity are completely different. So we cannot provide the same solution that we are providing to some tea estate of Darjeeling and to the tea estate of Munnar. So we should go for localized and customized solution. So that is also taken care in this work. So I am not going into the methodology, I am just discussing one by one modules. So here you could see some photographs of our project implementation of some photos we have given. So there are different modules, I will come to that. So this is during the training of the local farmers in a tea production unit at Lataguri towards region. So this is a training for the local, local hotel owners, homestay owners, the local drivers, restaurant owners. We have trained them regarding our technology. Then we have reached for data collection to Meghalaya and Assam region. This is also a awareness camp among the tourists who used to visit. And this is an awareness campaign about our technology to the different primary school teachers, so that they can use our technology for the betterment of the students in that region. So let me discuss one by one that what we did and what are the things, and obviously we will be very happy to provide your feedback so that we can modify our work according to your feedback. So there are some modules. So I'm thankful from here, actually basically my students developed this PPT from this portion. So I'm thankful to Shamrat and Rajkumar for their contribution here. So the first portion is the smart tea farming, as I mentioned. So what we will be doing, we will be collecting the data continuously for environmental data and soil data. Then precision farming, as I mentioned, we will be providing that at which location we are taking the data in centimeter level precision. Suppose why it is necessary, let me give you one example. Suppose one black dot disease is started to be spreaded in a tea farming area. Now tea farming area could be a acre, 1 acre, 2 acre, something like that. Now, yes, that question comes from one tea estate manager कि मेरा लेबर तो घूमते रहते वो देख लेगा कहाँ पे डिजीज हुआ है वो कर लेगा ट्रीटमेंट. Now the issue is that your labor you are believing on a manual interpretation. Obviously he might be correctly he might be identified, but still we are providing you the real time data, whereas your labor could be 12 hours late or 24 hours late to identify that location. So what will happen, by that time it will spread further. So to stop that, our solution is that identify and provide the solution immediately, so that you can apply pesticide or apply medicines, or you can simply discard that leaf so that it cannot spread further. So that is just one example why precision is important, because our precision is up to centimeter level. So what location we are telling, you will be getting your problem in that exact location only. Then artificial intelligence. So obviously for predictive analysis and decision making, we are using the machine learning models that comes under AI, and we have one GPU for that. Then wireless transmission. So the sensor, whatever the data they are collecting, the environmental data and soil data. We are transmitting wirelessly using GSM and Wi-Fi modules, and we are storing it into clouds, and then it is processed on machine learning to make the decision. And these things are actually the unique things. I will show you, demonstrate our website that we didn't launch yet because we have applied for patent, and the patent and copyright is yet to be granted. Hopefully within a couple of months it will be done. So then we will launch it officially. But I will show you that what are the features there. In digital tourism, like because I stayed almost 8 years in Sikkim, so I know the pain when a person used try to travel in a location, hilly region. So suppose I am traveling alone, or I am traveling with my small family. Then sometimes we don't want to book the entire car. We don't want to reserve the entire car because it could be very costly, it could not be economical to me. Whereas in the same train, even in the same compartment, there might be another co-passenger who is also going to the same destination, but we don't know each other's destination. So that's why we could not club each other, and we could not afford the same car. So our solution is like for such people, they can will be providing them the real-time availability of transportation. So that is one thing I mentioned. Apart from that, homestay. If you visit in the areas, there are many people who are running their homestays, but mostly there are middlemen. They are involved, so they are taking a lot of money in the name of providing a service, and the real person who are owning or providing the services, they are not getting the benefits, and that is true for the agriculture industry also. So that's why the benefits are getting someone whose contribution is not that much. To stop that, we are providing a direct interaction between the homestay or hotel owners with the end user or the tourist. Then we are providing the shopping and suppose wherever we are going to some place, we are interested to purchase the local product. That is all of us. We want to purchase their authentic local product. We want to taste their authentic foods. So there could be some artisan in that region. There could be some authentic restaurant or food supplier. So we are providing a platform so that they can be connected with the tourist people or end user people. So all these things, even for tour operators, suppose I am a tour operator, I can provide all these services. So they can also register in our platform and they can take the benefit of this service. So this is one thing we have developed here in the name of digital tourism, and tourism related digital services. Second thing is the e-learning. Now, this e-learning is one kind of societal responsibility we need. We have developed our platform for different, because in T areas, T levels, they are actually very underprivileged. So they don't have sufficient education facility and other things. So what we thought, what we are trying to do, we are implementing the AI-assisted learning models there. We are integrating audio, visual, textual things all together, and we are classified it into different modules. Like whenever we are starting our education, it starts with pre-primary, then primary, then upper primary, and so on. So we are targeting one by one, and at the beginning we are focusing on 3 subjects mainly. One language, that is English, because it's the common one required. Then mathematics, and what else? Science. So science is the general science. These 3 topics we are actually considering now, and it will be the AI-based progressive learning. AI-based progressive learning means, suppose I completed one module, then some quick interaction will be there along with the user. Now based on the user's reply, our system will be understanding that up to which level he or she learned, and then the next module will be customized according to his or her learning pace. So that is the AI-assisted progressive learning that also we are implementing here. So these are the flow. First is the IoT sensors that is used for real-time data collection. Then PDK-based GNSS for precision. Then cloud platform for data storage. DIML for decision making. Web or mobile app-based Android application for to showcase the outcome. And the project outcome. These are the expected outcome. Let me just skip this part. Let me skip this part. Skip this part. Okay. So these are the methodology. Let me discuss one by one. The first step is the identifying the requirement of that region. why that region is lacking in quality or quantity of the production. Then what are the sensors required to collect the data? We need to identify those sensors. Then we need to develop the GNSS robot unit. Then we need to transmit the data wirelessly. It is very simple to say, but it's very challenging to implement. Then making machine learning based decision making, and finally visualization and deployment. So let me just show you the overall schematic. Just a minute, because this things will take too much time. Okay. So if I come here, you could see here our complete system module. We have started with used the Raspberry Pi board, although it can be replaced by Latepanda as well. So Raspberry Pi we have used, Raspberry Pi B4 we have used because it is comparatively cheaper solution than Latepanda. Then here we are having different sensors input step. Starting from this side, we are having some environmental sensors like raindrop sensor, soil, then proximity sensor, temperature sensor. This type of multi-sensor modules are there. We are having NPK sensor. NPK sensor is used for nitrogen, phosphorus, potassium. This levels we can identify what is the proportional available in the soil. We have used the soil moisture, soil conductivity, soil pH level. Everything we can measure using the sensors. Then that is the IoT part. Our system is supported by a power bank, so that at least for 2 days, 48 hours, we can take continuous data, and then we can replace the power bank with another power bank to again collect the data. Then for GNSS part, here we have, this is the GNSS module. Here this is called uBlocks JDD F9P. uBlocks JDD F9P is a receiver module. So these two receiver modules. This is the base station antenna. It is survey grade antenna, Arctic antenna, survey grade Arctic antenna. It is connected to the one receiver, which is uBlocks, and at the rover end, this uBlocks is added with the multi GNSS antenna. This is L1, L2 band antenna. We have developed it by ourselves. Obviously, in market there are many patch antennas are available, but obviously we should have some our own contribution apart from depending on the market. So then, whatever the data collected, that we are transferring wirelessly to the server. Now this server data collection, and then it is kept in the cloud storage, and finally that we are producing that decision in the app as well as web platform. So this is the complete schematic of the entire project that we are implementing.
Sir, question.
Yes, please.
How sensor identify soil quality?
Sensors are actually not identifying the quality. Sensors are made for different parameters. Like suppose one parameter is the soil temperature. So let me make it can be manufactured in different way. What is the one very popular, because my areas belongs to RF microwave also. Suppose you make a dielectric based sensor. In that case, that sensor is having a scattering matrix parameters. Right. Now, when you are keeping it in room temperature or in any temperature, its characteristic will be something. When you are changing the temperature, that sensor's scattering matrix parameter will also be changing. So, by considering the change, it can give you that what is the plus minus value added with the threshold temperature. So, that is just one example of one environmental sensor. So I am showing you just after that all the sensors are discussed in detail one by one. Here like Raspberry Pi board that we are using. So here you could see that this is the heart of this entire system, because it is connected to all the sensors, and it's the microcontroller board. Whatever the data it is getting, there is a ADC is required to add it with that, and GPIO interface is also there. And we are also having a camera module to take the real-time photographs to connect the data. And for transmission of the satellite navigation data, we are even connecting the Raspberry Pi with the JDD F9P receiver board. Then if you go to the next slide, so this is one NPK sensor, which is again one of the major sensor unit of our whole project. So in this case, in this NPK sensor, it can give you 7 parameters. So it's a different NPK sensors are available in market. So basically, it can always NPK sensors will be giving you nitrogen, phosphorus, potassium. This is level. How much nitrogen, how much phosphorus, how much potassium will be there in that ground. Now in that case, such NPK sensors which only evaluate 3 parameters, its cost is little less. We have considered a moderate NPK sensor which provides 7 parameters and it costs around 12,000. Okay. So in this sensors we can measure soil temperature, soil conductivity, soil pH also, and it is directly compatible with our Raspberry Pi board. Then
how the sensor understands the pH level?
Actually, I am not an expert of that portion. So frankly speaking, so you can also search it. I have to also search it because I am not going into that level. How sensors are, what is the working principle of the sensor? I didn't study, so better I should not answer. Because for other sensor, dielectric sensors, I can tell you because I developed many dielectric sensors and this thing. But NPK sensors I never developed, so I could not answer. Yeah. Then DST11 air temperature and humidity sensor. These things are very low cost. I think 200-300 rupees you will be getting it even in Amazon and these places. So that is used for temperature monitoring and this thing. So this also you can make a dielectric sensor. Instead of this, but if you make it for dielectric sensors, that will be a PCB based and cost will be much higher than this type of simple sensors. And then gas sensors, air quality monitoring sensor. We have used proximity sensor to whether any insects are coming repeatedly in front of the tea leaves or not to detect that. Then raindrop sensor to identify what is the rain perception and probability in that area. Converter is used because this analog data into digital one to make it understandable to the Raspberry Pi module. Camera module is used for image storage. Especially for the disease detection, this module is very much useful. And power supply, this is a big challenge. In our project, we have mentioned also solar cell, but the solar cell till now we didn't deploy because solar cells are again there is another challenge to keep the conversion. So we are providing an alternative way with the help of power bank right now. This is the GNSS part. In GNSS part, we have used U-Blocks. U-Blocks is again a very affordable solution for receiver because if you go to other solution like Java and other companies receiver, they are very highly costly. This is low cost. Obviously, there are some drawbacks because in low cost we need much more numerical analysis. So computation and numerical task will be heavier in this case. But we have developed our own algorithm so that we can make it compatible even at low cost. So that is one great achievement we did, that at a low cost we are providing very high precision. So it is working on L1 band, L2 band and L5 band and mostly we are getting GPS Beidou constellation in India. That is true for any receiver board. And it supports SPP, PPP, RTK, PPK, all 4, but we have used PPK only. And it cost in Indian currency, I forgot what I believe, around 30,000 something it cost that time. So this is Skytrack survey grade antenna. This is the base station antenna. ये सब चीजें हम लोग लाए हैं. We will demonstrate you these things, how it operates this thing. So Skytrack survey grade antenna is for base station. And then these are the market alternatives of patch antennas, U-Blocks patch antenna, BNN patch antenna. But what we developed, let me show you. This is the antenna that we have developed. In satellite communication, we don't need linear polarization. Our antenna need to be having circular polarization. So that's why you could see the feeding here. Feeding is asymmetric. It is not in central, because if you keep it in central feeding, then it will be linear polarized. The LP antenna will be getting. Because of the asymmetry, we got this circular, if you see the surface current, you will be getting this circular rotation here. So it can clearly see. So this is the circular polarization we have achieved, and it is working on L1 and L2 band. So these two bands it is working, and this is the axial ratio bandwidth. Axial ratio bandwidth says if it is below 3 dB, then it reflects it is giving CP. So here in both the cases, around 1.2 and 1.53 or 54, we are getting the CP. So these are the CP patterns, which is directive, that is again required. And this is the way to do the GNSS things. Like first we have to configure the GNSS antenna into U center. Then we have to do the GNSS data collection. Data collection will be for 24 hours for base station, and for rover it is minimum half an hour required, but for safety purpose we took it for 1 hour. And then there is article library. In UBX and RENEX format we are collecting the data, then we do post processing, and MATLAB is used for error calculation and final result evaluation. In this table, the standard data is available, that is collected from internet. For any TS state, these are the suggested data in ideal situation. It should have a nitrogen level in between 150 to 250 milligram per kg soil, phosphorus 10 to 30, potassium 200 to 300. pH level should be not more than 5.5, but around 6 sometimes. Air temperature should not be more than 30 degree, and humidity should be around 80%, something like that. So that is an ideal environment, but again I should mention it changes with the change of geolocation. The same data is not, these data are specifically for North Bengal and Darjeeling region, but in other region it could little differ. So these are some case study that we did. So first we tried our experiment in our own campus, within campus. So within campus, you could see this is the base station arrangement over a tripod. We need a free space. मतलब satellite के ऊपर अगर तुम चारों तरफ से covered रहेगा, then data will be very disturbed because of the multipath, and our data quality will be very poor. So we have placed it on the rooftop of our laboratory using a tripod, and then we connected it using the cable, coaxial cable, to the laptop. And similarly here you could see this is the field setup. In the field there is a rover data is available. Rover module is there, and that rover module is connected to the laptop again for data storage and post processing. This is IoT within in-house IoT data setup just for testing and verification. So some simple data plotting is there, like reading of NPK sensors, what is the level of nitrogen, phosphorus and potassium. You could see in different time frame. So it was taken for almost 6-7 hours data collection was there. Similarly, we have calculated the humidity over time, and there are a lot of other data available also. So humidity is decreasing over time, and other soil data like soil moisture, air temperature, these things were also plotted. Now in the first result, when after post processing, what we are getting, you could see for two different locations we have placed the rover. In R1, the first location, the rover is 1.5 kilometer away from the base station. Now if you could ask that how we measure this distance. Now this is not distance like ground distance. This distance is the aerial distance. So in aerial distance can be calculated. There are so many apps are there. They can predict what is the aerial distance in two location. If you on your GPS, they will give you the location. Obviously there could be 5% error, but somehow you have 1.5 kilometer and 0.5. So this is a very close proximity when we are keeping the base station and rover, and this is in moderate proximity. And we have taken multi-GNSS constellation. The first one is GPS with Galileo and QZSS. QZSS is Japan's regional constellation. Next one is GLONASS and Beidou. In region 2 we have used GPS, Galileo, QZSS and GLONASS, Beidou. And these are the different error calculation methodology: 2D RMSS, CEP, SEP, MRSC. And in all cases you could see the precision, it is in centimeter or even in millimeter level. So this data you could see. So that is the point, you are getting millimeter level accuracy using the PPK. Then we have started our field investigation. Last year in 25 we have completed field investigation in 2 phases. We went to Lataguri, Duars region, and in Duars region we have tested. We have kept the base station just top of the hotel. There we kept the base station, and then we roam around different tea gardens and placed the rover unit as well as the IoT unit The whole IoT unit was, within the plastic enclosure. The reason is that sometimes rain used to come, so just to protect it from outside damage, we used to that casing. So again here air temperature was measured for a longer duration, air humidity was measured. You can see the data, if I read it like 32 degree to 22 degrees, the variation over from mid of the day to the almost at 6 p.m. you could see the downfall of the temperature. Similarly, humidity is little increased and then dropped because it solely depends on the environmental situation. Then data related to the soil characteristic we have taken, like soil temperature, soil moisture, soil conductivity, the availability of nitrogen, phosphorus and potassium. And these are the post-processing results for satellite positioning. Here again we are getting millimeter level accuracy. And the third experiment we have conducted in Assam and Meghalaya region, just in April month of May month of this year we went there. 31st May we went, so it is the first week of June basically. We went there and we conducted these experiments. So here also we have checked the humidity. Humidity is obviously much more in that case because the Assam Guwahati we actually have considered the data. So it is just at the bank of Brahmaputra river. So because of the presence of Brahmaputra, the humidity is very high. Then temperature of soil and conductivity, same data, same set of data I have calculated. Now after collecting the data, our next task is to feed this data through satellite to the server and then processing in that server. So that thing we are doing to make the decision. So that is the ongoing process. So I could not show you the exact result now because due to the privacy, because patent is not yet published. So that's why we are keeping those results with us for the time being. It's sorry for that. Okay, let me just show you the website part because these things already we have discussed. Okay, so please. No, there are, yeah.
Because taking the data, the sensor part, that is not the risk. The one that is playing, how do you...
Yes, the main challenge is actually basically few challenges are associated because getting data is also somehow challenging. We need to optimize the cost if you increase the number of sensors. Because sensors and these things need direct proximity to the ground or air. So if you are sensing data at a particular location, after a certain range, the data set could change after certain geolocation. So that's why initially we have to identify how many how many total module, we have named it ISGUS, that module, how many modules we need for part T estate. So then we did that floor planning and that is varying in between a range 4 to 6. To cover nominal or the medium-sized T estates. So that is what AI-based predictive analysis we did. Then second challenge comes, as you mentioned, the biggest challenge is data transmission wirelessly. Because big data we are gathering. Whenever we are going in some location, we are taking data for a couple of weeks, 15 days, 30 days, sometimes with their help. So sending those huge data wirelessly. And not only the IoT data, sensor data. Apart from that, the GNSS data also we need to send, satellite positioning data. So that is again a big challenge, how to transfer the data wirelessly with very nominal cost. Because our main goal of this project is to make the solution affordable, so that end user should not suffer a lot. So that was a challenge.
So much of data has to be stored somewhere.
Yes, there are two ways. Either you store them post-process. But as per our project idea, it will go to the cloud directly, and immediately there will be our own algorithm, and then decision will be there, and that decision will comes to the display, like in Android application and web platform. And the end user, the farmer or T estate manager, there will be the access of the application and the web page, so they can get the end result instantly. But obviously, any machine learning technique depends on the data volume. If you gather more number of samples, your data accuracy and precision will be much better compared to the less data. So that is a big challenge. T crop cycle, for a full crop cycle, we need to collect the data for a particular location. So these are the challenges actually we have faced during the implementation.
While sending those data, it has to be at first filtered to some extent that how much should be sent.
No, it is not filtered, it is compressed. Compression is much more important before transmitting the data, because filtering mostly happens if there is a noise propagation or backscattered wave. But we are taking direct data, so there is no backscattered data are not there, because it is not any reflection based data we are collecting. We are just coupling it to the ground and directly sensing the data. So
some specific features or some kind of reprocessing of those data, so that this much could be sent, this much may not be sent. So,
what we did parallel processing of data. Like, so satellite data is transmitted. Parallelly, we are transmitting IoT data. Even IoT sensor data, we are doing concurrent transmission for different modules. Like soil sensor data, we are transmitting. In parallel to that, we are transmitting our environmental data, like environmental temperature, humidity, these things. So because of this parallel processing, we are using different transmission technology. So that's why it occupies different channel. So at the same time, we are sending more data without what you are suggesting by doing some pre-coding, restriction of data. We are not restricting data, we are transmitting but in parallel. But what we applied compression algorithm there to compress the data so that its volume could be less.
for example, if there is a location from where some data is being collected, there is some take data is getting sent, some other data is also being sent. That is not going to change over say 10 minutes to 20 minutes, 30 minutes. So if you take a sample after say
that is called, that is not sample, that is called periodic data collection. So periodic data collection also possible, very correct, but that I already mentioned, that we did. So that's why I said at the beginning, we have to identify what should be the number of hardware prototype to cover the entire region. And based on the periodic solutions only, we have divided it into 4 to 6. Now problem is that when we are implementing it manually, it is okay. Some person like me or my student could go there and just change the location. But if the system, because when we have to implement it in realistic manner, it is not possible to deploy a manpower there to change the location every time. So we have to take help of some drone or UAV module so that it can be changed in a different location. So we have thought of that and we did exactly so as you were telling, in periodic data collection. But that period is at least 1 hour for our case.
that will not be possible to make it programmable. To say some timer or something like that. So to say that
No. Let me again tell you. Suppose I am collecting. Suppose this is my hardware model. I am keeping it here. So I kept it here for 1 hour. I got the data I required. Because 1 hour is the minimum time you are considering for satellite precision. For TPK, it needs to be 1 hour. So suppose I am taking it for 1 hour. Then what should I do? Should I stop it and place it here? That is not a good idea. Instead of that, if I utilize it in a separate location, so that's why the movement is required. But by programming, it is not possible. I need to have some autonomous transmission or manual transmission. So far we did manual transmission, but that is our next scope. We have to make it integrated to the UAV so that UAV can took it to a further location. So now we'll give you the overview of the digital platform. So here we did launch our actually website name is Uttaran Setu, and that is exactly the name of our startup, Uttaran Setu. We have started that startup very soon, I think 2-3 months back, and we got some incubation funding of 10 lakh. So let me check whether it is hyperlinked or not. Okay. So, Shamrat, is it possible to open? Please check. Internet connected है या?
কোয়েল ম্যাম বসেছে, ফোকাসটাকে একটু সরাতে হবে না কোয়েল ম্যামের দিকে।
Okay, so this is our digital platform. So it is still not launched officially. So in this feature, you could see this is the home page for this platform. So now obviously we have kept it some account-based restricted login. Otherwise, anybody can access the data. So to protect it, we have made it some restricted access. So just login, user-rated password. Okay, so these are the different features we are having in this platform. You could see. So first one is the accommodation module. So here you could see that a dummy information is given. Now one could simply ask me, there are a lot of booking websites like booking.com, Agoda, Go, Make My Trip, many things are available. What is the difference? Right? So, if you book through those platforms, they will be deducting some 30% from your booking amount as they are charged, and they will take control of the payment. You need to pay to that aggregator or to that service provider, and then they will book your reservation. But irrespective of that, what we are providing a direct chatting box. So whenever you will be selecting after doing the filtering, so we have shown some filtering here because this is under construction, this page. So here we have shown some limited filter models units, so it will be increasing day by day. So suppose you want AC room, so you will be keeping that, and then you will put in enter button. So you will be getting some list where it is available. Then whenever you will be clicking some module, there will be a direct chat availability because users mobile, the service provider, the hotel owners or homestay owners mobile, a message will be sent that someone is interested in your property. So immediately there will be a direct interaction between your property manager and that tourist or whoever will be utilizing that facility. And we are not taking any financial liability on us. Right. So it is the tourist's responsibility and the service provider's responsibility regarding the financial things. We are not gaining anything based on the financial matter. So we are providing a direct linkage between the homestay service provider and end user. So that is the motto here. Now, if we see the other modules, similar for transportation. So in transportation also, you could filter your requirement and you could do that. But one added advantage is that it will be showing you the live availability of the seats, so that if you wish to make some clubbing with other tourists, you can do that. So that option is there. Third part is the cuisine. Cuisine means local food and local restaurant owners. Again, some filtering option will be there, and the direct interaction between the, even you can make direct request to them that what type of food you are preferring from them. Then this part comes under shopping of local cuisine, local artisans, so they can sell their products directly to the tourist or directly to the user. It is not mandatory that we will be taking care, like Amazon or Flipkart will be the sending or dispatching the things. Rather, it is the responsibility of the the owner of the product. Either they will be courier it, or whenever you will be visiting that place, they will be sending it to your hotel. Obviously, then at the cost of their price of that unit. So then these are some data required before going to any location. So those things are provided here. Some information regarding any tourist places. These things are will be incorporated in this module. And then let me come to that portion. This is the agricultural portion. So here the real-time data of any tea farming location that you are interested, suppose the temperature data. So then it will take some buffer time because real-time data analysis is going on there. So even it depends on the net connectivity, sensor connectivity. So these are the last data it is showing. So this whatever we will demonstrate today also, we can connect it and we can get the data. So this type of data availability will be there, and according to the data, what should be the correct requirement. Even for pesticide, how much pesticide should be applied at which location. So this type of services will be adopted here in this location. So the location wise, whenever you will be clicking in that location of your tea farm, accordingly the data will be provided. So these are some other information related to tea. Let me just skip that part. And this is the e-learning module, as I told. We have classified it into three categories: the pre-primary, primary, and upper primary for the timing. And so, if we go to any portion, then we will be having some textual, video, this type of links will be available, and then there will be a AI assisted chat box after that for direct question answering, and then evaluation. So these are things incorporated here, and some basic informations are also there who are involved in this project and these things, so that is not required to demonstrate. So these are just some glimpses we have shown you. So these are again the same things that already we have discussed. So this is one important part. So any feedback, then I will discuss this part. This is the one serious glitch of this system is that suppose I am a fraudster. I just gave some fraud data. Yeah, I am having this homestay. So in our system, we must have some verification whether you are an authentic owner of your property or not. Otherwise, anybody, we are actually providing the license to the fakesters so that they can fake it. So to restrict that, we have made owner verification and approval system. So the basic concept is that suppose I am willing to listing my property there. So what I need to do? I need to upload my registration certificate. Suppose I am having a shop. So then obviously I will be having trade license. So I need to upload that, and our AI assisted verification, because nowadays most of the certificates are digital certificate, and that can be using the barcodes, it can be identified whether it's a fake document or a real document. So that identification we are implementing, and it will take 24 hours to complete that identification, and then only we will be generating the user ID and password for that user. So that is the authentication and approval system we have incorporated here. Okay. So what is the purpose of this project? The basic purpose is to empower the tea community related people. Like in tea community, if you consider, this is one serious issue. Different governments are coming to power in different states or nation, but the problem is still there. If they are not making money, or it is not a profitable deal to have tea estates nowadays. So how to make money? There are two ways. One is you make your tea production better, quantity and quality you improve. Second is you have to identify the alternative way of earning. So alternative way is, if you are having a tea estate, why don't, because most of the tea estates are having very good bungalows and British era buildings. So why don't you open it for the tourist people? So we are providing that services. Apart from only the tea people, tea related community, there are surrounding neighborhood, they can also utilize this facility. They could develop their own homestay. They don't need anything. We are not charging them. So they can just register their product, they can list their property, or they can list their car service, any facility what they are providing, and they can get benefit of that. Similar for local artisan. Suppose some products they are making using bamboo or something like that. So they can sell it directly. They don't need to pay to any other aggregator like Amazon or Flipkart any commission. So they can use their service directly here, and we could have a direct interaction between the user or the tourist and the artisan person. So, and second thing is the e-learning. So e-learning supports the laborers who are the T-laborers, their children. They can take some quality education with the help of technology without depending on the conventional school education. Apart from that, because nowadays self-learning is very important, so it can assist them for their self-learning. So these are the purpose, so that it can create a great societal and economical impact among us, and it should include, it is inclusive, like it is not excluding any part. So we are trying to include all the different majority communities there. We have the data also. That project submission, we have submitted those data. What are the different, based on caste census, based on professional activities, what are the percentage of people are involved in what type of profession. So based on that, we have formulated this project, which is suitable for all types of communities related to the T. So if we conclude our work, technology side, we have integrated few things like IoT, GNSS, cognitive radio concept, antenna engineering. These things are integrated. So multidisciplinary integration is there, AIML is there. Then we have solved some project which is having real life application, which can give direct benefit to the underprivileged section. Tea is one of that area. Obviously, it is not restricted only tea farming. Same concept we can implement for potato farming or any different agricultural sector. We have provided some alternative earning based on education and tourism, so that it is not only solely depends on the agriculture. Other prospectors are also there. We have studied in different regions so far, and we will be visiting a few other locations as well in future. And okay, so before concluding the session, I will tell you what we have planned. We will be doing some quick demonstration of our modules, the IoT modules as well as the GNSS module, because GNSS might be new to many of us. So you can keep it ready within 5 minutes if possible. Okay. And what should I say? I don't know whether I should say it or not, because that is not a part of this lecture. But from my very small experience, because all are respected faculty members here, as I was informed. So nowadays mostly 4 P's are the fundamentals of evaluation to any organization. What are those 4 P's? Publication, patent, PhD production and project. And they are actually making a chain. So please apply for some projects. I don't have that presentation because I used to give that presentation more frequently now in different institutions. How to write good research paper and good research project and how to grab good research project. So one thing I could assure you, the mindset, because we are having the mindset, and that was true, quite true. If we are in not a centrally funded institution, they might not be allowing us for project grant. But that is not always true. Especially in ANRF, there is a direction was given from the PMO, and PM Modi also he mentioned as Joy Anushandhan. He has given that slogan, and that time it was clearly mentioned that 95% of our students are associated not to any centrally funded institution, not IITs and NITs. Whereas it's vice versa. The project allocation are mostly to IITs and some NITs and some big state universities like Jadavpur and some others. So there is a direct instruction. You should reach to all faculty members from other institutions as well, so that all have the equal opportunity. And it's truly believed, and my experience is also very same. The students of such institutes are very enthusiastic and they are really contributing to the work. Because we never got any student. I could say I didn't ever, I tried a lot, but I never got a student so much motivated from our institution. Because from day one, their target is to get placed. And they know that is the tradition there, and they have already proved they got a good ranking, and that's why they got a seat there. But whenever we took some students for internship from other institutions, so the students are actually, they try to prove themselves. They want some opportunity and they really give their best to prove themselves and they really contribute in the project. So in this project only I, provide internship almost 26 students till now. So most of them are from Jalpaiguri Government Engineering College. I believe last year it was 7, this year also 10. So 17 students are from Jalpaiguri and few others from other institution. So all total 26, 3 students are from Jharkhand Technical University. So all total 26 students got their internship. 2 PhD, they are actually project manpower in this project. One is project associate, another one is project assistant. They are doing their PhD under this project. And 2 MTech students also completed their dissertation. So we need manpower that we are getting, and also I request you all of you to please apply for project because funding is really challenging. That's true, very challenging, but it's not impossible. It's very much possible. And some of my friends, they are also in private institutions, but they got good projects, and it will help you because if you get a project, obviously you will be getting a project manpower, 1 or 2 manpower. Those manpowers will be assigned as your PhD student. So your project outcomes gives you PhD scholar. Again, there will be some research. That research will be counted as your research publication. So third P is also solved. And fourth P is patent. So nowadays, actually our institution is having one opportunity. If we got a patent grant, we are getting 100% reimbursement of our patent cost. So usually a patent cost is around 40 to 55,000 roughly, even if we keep it in a lower side. So that much reimbursement we are getting for our institution after granting, and after publication we are getting 75% reimbursement. So that is a good opportunity for us. But you can keep that money for in your project also. So at least one patent can be done from the project money. Because I did 2 patents from another project, from the project fund only, not from the institute fund. So I request you the same thing. The 4 P's are very much associated and that will help us ultimately. Okay, thank you for giving me this opportunity. We'll be having a very small demonstration session very quickly. It will take few minutes to keep the things ready, sir. Yes, please. Yes, please.
So, why we need in this project the millimeter level accuracy in GPS?
Good. So, very prominent question. Why should we have GPS can provide meter, 10 meter level accuracy? Why need to centimeter, millimeter level accuracy? As I mentioned, the one reason is that suppose one disease is about to be spreaded in a farming zone. We are having a camera module that gives you 24/7 real-time image, and we have developed the image the prediction of disease. So if disease is predicted, instantly warning or information will be sent to the owner or subscriber of our system. So instantly he can take the solution. Like we will also suggest, if it is known disease to us, then we will be suggesting the solution. He can apply that. Otherwise, he can remove it. So what is happened? The most of the disease can spread very quickly. So instantly, if you cannot take the measure, it will not be a good solution. That is one thing. Second thing, it is related to irrigation. Some portion irrigation requirement is more, in some portion it is less. So that accuracy can also be done in centimeter level. So these are the some examples. And suppose insect is affected by some part, and repeatedly due to some known or unknown issues, some insect is used to come in a particular portion. It is not for tea, but for potato farming it is much more there. In potato, dhasha is a very very well-known phenomenon. So that used to happen very quickly and it used to spread very quickly. So you need to remove it as soon as possible. So these things will be very possible only if you can accurately detect the location. So that's why we have proposed.
To use drone.
Yes, drone can be used. Although we didn't consider drone because again our project is already having so many technology. So drone is mostly used nowadays for irrigation easiness, because it reduces the manpower dependency and you can do this with limited manpower. You can control your whole farming area with drone. But in our country, human availability still much more easier and much more affordable compared to the cost of a drone and this thing. Because if you purchase a drone, you are not allowed to operate the drone until or unless you are having that license. Right. So everything, if you consider the cost of calculation and other things, and the technology part, obviously there will be maintenance cost and other things. So nowadays the labor cost is not that high in our country compared to the developed countries. In developed countries, the manpower cost is very high. So that's why drone is a very good alternative for them. But still in India, our manpower wage, daily wage, or what we are providing in actual, that is not that high. Drone will be much more beneficial compared to that.
So you can we need to take the image manually.
No. There will be. We have shown you the circuit. Their camera module will be integrated. It will be placed. So your question is very correct. I accept that. See, I cannot make it manual interpretation. I have to install it with drone, and then there should be a surveillance. And then only we can detect the location, and then only we can take the solution, because it is not manual. But
location is not that much.
in case of manual, there is no necessity of location in these things, because 10 meter is not a big deal for a human being to go and search. But obviously, I am telling you, this solution is for autonomous.
When we use autonomous, then why we not going for vertical learning? Vertical learning reduce the manpower. And it will.
No. If you see, this is not this is project is for tea farming mostly. So in tea farming, already they are having the land, they are having the conventional practice of good tea farming, and we have to accept that. Right? We cannot change the 180 phase shift to them.
So then we can go for rope camera without drone. We can by using only two stepper motor, we can hang some camera which can detect XY coordinate and the
Yes,
millimeter position.
it can be done. There are two things actually associated. We want to make our system very compact. Right? So when we are integrating the camera we have proposed, the camera module, it is directly connected to the microcontroller board. And the same microcontroller board is used for the sensors as well. The sensors are directly coupled to the ground. And when the camera you are saying, that should be placed somehow little above of the ground. So that two are contradictory in our case. So we are keeping camera module little high from the ground, but because tea leaves are not very big. It is not very big compared to the other leaves. So that's why it was possible.
Then we can any robot hover kind of
robot. Can you imagine the cost behind robot? Because one of my friends is having that startup and he developed robot for drainage clearance. जो अभी manually manhole वगैरह cleaning होता है ना, to replace that he started a startup. Robot will do all these things. क्योंकि there is a verdict from Supreme Court also. You cannot send labor for such manual cleaning and these things. So that's why he started this business. And I asked him, what is the cost to develop one such robot? So I am telling you the cost of 1 year back, last time I met with him. So he was telling that time around 66 lakh. So we have to think the affordability. Our system that we have developed, all total, it comes around, per unit it comes around 40-50,000. So I cannot compare it with that cost.
That is the actually this technology, millimeter level accuracy, you can use it in different for different.
No, it is already there. Its application, it is in GNSS is not developed for agriculture. GNSS main application is for satellite clocking. Okay, satellite clocking. You suppose the time you are getting, the time synchronization जो होता है ना पूरे इंडिया में same time synchronization जिसमें official काम होता है. That synchronization and satellite clocking is related. Where that precision is very much relevant. But this is one alternative application we are providing. I have never said that this is the only application or this is the best application of GNSS location precision. This is one of the application I say.
For that we can take the image
You can, if you wish, you can just replace it with the GPS sensor, GPS module. GPS modules are also available over net. If you don't wish, you don't go for multi-GNSS, you just keep GPS solution. Right.
But we have to take both from above, image from above.
That is for camera module you are saying.
Yes, camera and same
That is
time
for
ground.
sensor.
Yes. So one thing, using one thing can it be possible to?
Yes, that depends on the mileage. So if you see the camera modules in reality, it is having some 2 meters, you know, the extension. So that's why it is possible.
So while this is being demonstrated
Yes.
into Java, Vihansha Anchi sir, yeah, it is very good.
Ten minutes break.
5 minutes into Java.
Yes, yes, please.
Like a daily course also. Sorry, no? Cha biscuit আছে। Cha কে আছে?
Kind of business, you can use one single device or sensor module and without using that combined like 7 in one sensor module. And you can use
within the size of the district. The environment and the soil is not changing. Like if you be here, within after 500 feet it will not change. Almost same.
Biscuit also no.
another temperature sensor which is separate
The connection is not a big thing. It is how many people you are collecting. And if you collect millions of data, that will help you to do better solution, better prediction. It's machine learning, whatever the data you dump in to train your model, that is very important. If you make a model train with 5,000 data, if I train with 10 lakhs data, my model will be much more accepted and much more better than all of this. Data volume is important. Because what target is not to just collect data and tell that this is the temperature. For that we don't need this type of system. My role is to collect the data for a complete crop cycle. Then to tell from the next crop, you have to keep temperature this much. You can use shunt set. Suppose rainfall is more there. So we have to make some arrangement so that the range can be protected up to the level little bit. If it is not so sunny, we have to go for some electrical connection so that warm the lakes. So this type of solution we will be providing by analyzing the data. That is important. The data collection part I am not for that.